Oh, sorry. Oh, hello, and welcome. Sorry for the loud noise in the beginning. What a great start. Oh, thanks, Eva. Yeah, really appreciate it. Yay, hi. And what we're going to do is stream Excel. 7 viewers, cool. And if you don't know about this challenge, there is a command. And Ace also. Awesome. Inheritance, cool. Yeah, I was thinking about doing Python also, but I want to do something out of the ordinary. And for you who are viewing currently, welcome to stream Inheritance, by the way. You can take a look at what it's about. Yeah, something more fun. Well, I do Python basically every day at work, so, and also C in that work. So for me, solving it in Python is an interesting challenge, but still it's too close to work, and I never use Excel anyway. So I'm going to attack this problem. I have read it. I can say that I have read it, and I also solved it with a normal calculator today. So, but I have not tested my solution, so I didn't want to spoil anything more than just read the first problem. For you who are not familiar with the advent of code, I can start off by it's an advent calendar made from a guy called Eric Wastl. I think it's pronounced Wastl. Where each day there are 2 challenges. So today we have the first one has come up, which is the first problem, and the next day is in 13 hours, which is midnight somewhere in US, I think. And today's problem is about about saving the vacation. So you need to get 50 stars by end of 25th of December. Sorry. And by the way, I have mode this microphone, so please tell me if the sound is too loud or too weak or something. Each puzzle gives us 1 star, and each day there are 2 puzzles. So the first day we get 1 puzzle. First, when we solve that, we get the next extension to the puzzle. So yeah, and the puzzle is apparently that we need to get our expenses, fulfill our expense report, and there's something that doesn't add up. Which means that we get a list of numbers. My puzzle input is over here. And we should find those numbers are crafted such as, yeah, I read that the leaderboard doesn't count because of too many requests. Too bad. But anyway, there are more days, and it's about learning, it's about having fun. And I'm not aiming for leaderboard, at least. So, but if you do, you have 24 days more. So we should actually, so we should find a pair of numbers that adds up to 2020. And it's crafted so only 2 numbers adds up. In this case, they have found out that the numbers are 1721 and 2099. And our result is to multiply those. But the problem is that my input is 200 numbers. And I'm going to add it to Excel because I'm going to solve it in Excel. I'm going to put the simplest way, the way I've done it last year, is basically to always have one sheet called input, for where I can put all the numbers. And I'm sitting in the wrong corner, by the way. Let's see if we can, because you can see the input. I can scroll past it. Please tell me if I'm hiding something. So I need to find two numbers that adds up to 2020, and I can do it in two ways, basically. I can just add everything together, and then build a matrix and find where is 2020. I'm thinking about doing that because to find that I can do conditional formatting. So the question is, I can also do it a visual way, and I can do it a more effective way, like how to do it when doing programming. I'm thinking of do it the efficient way. That's more fun. There's more formulas in that way. I noticed something in this dataset. Just by looking at it directly, the first second, is that everything is about more than 1,000. Mostly everything is more than 1,000. Nothing is about 2020. Almost nothing is actually about 2,000, and it's just a few numbers below 2,000, which means that to add up, and nothing negative. So in case to get two numbers add up to 2020, one needs to be less than 1010, and one needs to be greater than 1010. And that's a fact that can be exploited here. And I don't see anything to be 1010, just to verify. Nothing is 1010. So there are two different numbers, one below 1010 and one above 2010 I need to find. Which means that I'm going to solve part 1 by looking how many numbers there are below 1010. If I can find those numbers, I can calculate what I would expect the other number to be, and then I can locate that in the list. So to be able to find all numbers below 1010, I can actually sort it. And sorting is possible to do in Excel by formulas too. It's directly possible just by going here and then take data sort, but that means I actually need to modify the input set. And I want to keep the input set already from the beginning, actually to be as original as possible. So lowest input numbers. Let's call them sorted input. Let's put 1, because if I can fulfill, I just need a helper column to get the index. That really helps when doing sorting. Because to get the sorted set of to sort the input data, I can actually get the lowest number with a function called small, which takes the column, the input set, and the first number, which means that I get the lowest number. Looking at what small does, I want to see if I can. Yeah, the help is actually quite useful. If you have any questions or anything, just ask. If you have questions related to Advent code, if you have questions related to how I solve something or how I might solve something in another way, just feel free to ask. everything here is about learning, and no question is stupid. Just ask. It's much more fun just to see if you have anything to. So at this point, small returns the k smallest number in an array, which means that if I enter 1, I get smallest number. If I enter 2, I get the second smallest number, which means that I can actually use this to sort. And I want to freeze that because otherwise I can. Oh, right. And therefore I have my second column here, which means that I can use the index actually to sort. Because that means that it's the first smallest, and then I go up here. And directly I see that if it's below 1010 here. So that means matching output. To get that number, I need to find this number in the dataset. Which means that I need to search the dataset for that number. And if I recall correctly, it might end up being a problem with one of those functions if there is no if the input dataset is not sorted. So if I can find this number, column C is locked, and if I can find in input $a, $a. Please ask me why I'm doing this if you are curious. I will find some numbers, but in this case I'm also need to have an exact match. Not available. And directly I see that I find 1018 and 1018 and 1002 on lines offset 67 and 134. So if I look here, it might be off by 1 by the way. 1018, 18 and 1002 and number 133. Yeah. Which means that I have actually found my two numbers. And here's the thing is that I can just multiply those manually currently, but I want to have some kind of info sheet here. Which means that I can, if I input something in input column, input sheet, I want to have the output here. Part 1 solution, like that. And I want to calculate that so it's automatic. To do that, I'm going to say that I'm going to accumulate here. And if is NA that 1, then I'm going to take the value from before. Otherwise, I'm going to take that number times that number, because that means that if I don't get an answer, I'm going to take the previous answer. If I find an answer, I'm going to calculate the product of those two. That means that this line is going to overwrite the previous number, and this one is going to overwrite. But since there are only 2 solutions, I can use the last one as much as the first one. And this works because I assume that there are just a few low numbers. Otherwise, this list has to be longer. So currently 0, and in this case, I got the answer here. So the last line should be the answer. So that means that I'm going to take that one equals, and I'm going to stick with it like that. So this should be my answer. And I hope it works. Yep, first problem, first try. So not even, it's actually one of the smallest solutions I've made in Excel. Thanks. As I say, I have not used Excel for 11 months now, basically. The last time was actually still Advent of Code last year. So just remembering function names is hard for me at this point. I'll get back to it. One of them of a starfish coin left. So this, if you have not seen the concept of Advent of Code, this means that now we're on part 2. So I got one gold star, which can be found when looking here as I got 1 star. But I need to get the other star also. And that's the second part of the problem, is that here I added something more. The same input data and usually the same, a bit of the same concept. One of them offers you a starfish coin if you had left. So, okay. Three numbers that adds up. If I have 3 numbers that add up, that's actually quite interesting. Because worst case means that one number is 0. That means that the other 2 numbers are exactly the same problem as 2 numbers. So I have still the limit of one number needs to be, if 1 is 0, one of the other numbers needs to be less than 1010, because then the third number is 1010. But since the third number has to be bigger because there are no zeros in the input data, the sum of the other ones needs to be lower, which means that 2 numbers must definitely be below 10,010. That means that I don't actually need to, I can do basically the same thing as do here, but in 2 dimensions. If I can calculate just by doing it, an addition of those 2, I can find out the sum of 2 numbers and build a list of that. Because this is 50 numbers, it says count 16 numbers. So that means that I have just 256 numbers as possibilities for the first one. So I'm going to do a part 2, two number sum. And in this case, I'm still going to use the trick here of, let's do 20. And pay special, I don't recall transpose, right? Which means that this is going to be a I'm going to use the this sort input column. Let's go row number like that. I'm going to lock A I'm not going to use the pure references because it works in this for the rows, because then I just can say that I'm using the part 1 B2 B35 and then B2 and then drag it out. But the thing is that when I go up here and transposing, it's a little bit trickier, and I like to keep it uniform. So if I copy the formula here, I can also do it like this, but instead I use the $C$1. So when I extend it in this direction, I get the same concept. I'm going to reduce the size a bit. So this means that I have each pair of numbers. The diagonal is not going to be used. I can't use the diagonal because then I reuse the same number twice. But in any case, I'm going to use that one plus that one. And I'm going to keep the numbers. So when I reference it, I can actually get the sum of all numbers. For this one, I'm going to use I'm just going to use backgrounds. So input data is green, helper columns is yellow, and so this is the result table. Input helper index, like that. So in this case, those are numbers that that's possible to add up for two values. If I just for fun go to conditional formatting, I don't remember where it is. It should be here. Conditional format, right. And I'm going to create a new rule that says that no, conditional formatting cells greater than those two numbers should never add up before about 1010. Which means that in fact it's only those numbers that is possible actually ever to use. So I have, and not even the diagonal. So I have 1, 2, 3, 4, 5, 6, 7 numbers to use. Which actually is quite interesting. So to simplify this, I'm actually going to, if this one is less than this one, then I'm going to use that one. Otherwise I'm going to use a high value, which is let's say 2020 because 3000, just for the sake of it. And the reason I'm doing this is that I'm actually want to be able to do the same trick as I did the previous round. I'm going to create a new rule, conditional formatting, equal to 3000, and custom format I'm actually going to use gray because that's not used. So we are only interested in those 8 numbers, sorry. So part 4, and part 2, number list, which means that I can still use the small in this array. let's go index first. Sum. I'm getting up to speed. Welcome to stream, by the way, Duda. If it's a 10-10 filtering sum tool. The thing is that I might be wrong. I don't think I'm wrong in this case. The thing is that when you have three numbers, let's say you okay, let's do like this. If you have two numbers, they say that number A plus B equals 2020. Sorry, let's not write over there. Let's say if A plus B equals 2020. That means that, let's say they are sorted, so A is less than B. We know that no values here are 1010. We have searched for that in the beginning, so we assume that nothing is 10,010 and you don't have a pair of that. That means that A must be less than 1010 and B must be more than 1010. No worries. So this is basically the concept of the fast problem. So in theory, when you look at a problem, you should find a pair that are two numbers that adds up to 2020. And I found those pairs here. And that's the part one. What happens in part two? In this case, we should find a part two that three numbers instead that are A plus B plus C equals 2000, like that. And this problem can actually, by the way, are you following with part one first? Great, because part two, we should get three numbers to sum up. 18.2, by the way. Please ask if there is something. No worries. So I have divided this problem. Great questions. Love it. So please ask. So I have rewritten this one to say that A plus B plus C equals 20. Which means that what I'm doing is that I'm focusing on this part to find those that are less, oh sorry, now I'm out of the screen. To find those parts that are less than 1010, because we know that this one is greater than 1010. So when I find the all pairs of AB, where the sum is less than 1010, I can use that to build the pairs like I did for part one. Does that make sense? So in this case, we have this line here is A. This line here is B. Which means that those numbers here are A plus B. And if I calculate 2020 minus A plus B, I get C equals. And that means that I can in next sheet, next page here. Sorry by the way, by sitting over the sheets. I came away from it. So in the next sheet, I am going to try to identify which values of C I get. 24 viewers. Welcome to the streams, everyone. I couldn't imagine that my first stream for this year using Excel should end up with 24 viewers. That's amazing. I usually stream other things which ends up with 5 viewers. So. But does that make sense, by the way? Martin also. So, hi Joanna, welcome to the stream. I appreciate it. Lots of you guys players also. So, doing so, I'm actually going to try to continue and to see that all possible values of C. So I'm going to clear this page and see if I can get something wrong. So you have all the pairs of input, let's call it input pairs, and get some of those. By the way, as you can see here, we have 2020, which is the sum of two numbers. Which means that we can see that this is a proper way to solve the first run too. For new viewers who are curious about what I'm doing, you can take a look here. So in this case, since I have the table, I need to lock it because I'm going to extend it and sort it, which means that right. No, you can't see. I can show you for, well, if I read it, I have the second part here. The second part is exactly as the first part, but there are 3 numbers instead of 2 numbers to add up. Excel guesser, love it. So, that means that I'm thinking a little bit about how to actually do it properly, because I would like to be able to see which number, which index I'm using here. I have one trick I can use, but it's a little bit messy and not the nicest. So I'm curious because I want to find the value A, value B, value C. So I want to be able to show value C. We know that since the sum is A plus B, I can actually calculate this to be 2020 minus the sum. So I know the third value, and I need to see if that's available. And to see if it's available, I can use the same routine as the previous one. But I'm just going to remap it. And this one is not C, but the E instead. So I'm going to see which one it is. So in this case, I can actually see that 855 is available, which means that that A times B times C, so I can actually identify 1165 and see that 1160. Oh right, you are right about that limit. Let's go about this conditional formatting again. Manage rules. I'm going to change this one to actually not that one. Cell value applies to edit rule. That's not the rule I want to edit. I want to edit that one. Why can't I edit that one? Oh, it was the right one. It says equals, but let's go. It can't at least add up to more than that one. Yeah, the A plus B can be at max. Yeah, exactly. Which makes sense. So we can actually do like part 1, the lowest number is part 1 B2. So let's do a conditional formatting. I think it should be possible to edit rule. Like that. I think it should be possible. Nope. In any case, there is an easier way. We don't care about those numbers. But that was basically just highlighting. So we know that 1165 is this number. So we have the solution is that number times that number times that number, but I want to have it easier. Oh, sorry. Which means that I'm going to look at match again. I think it's I'm not really sure that it's possible to since what I want to do is basically search for a coordinate. Hey, we make progress. It's a warm-up, basically the first round. But there's a little bit of trick here I'm going to use, I think, because the match can match in one dimension. So if I have a list, I can get the index, but if I have an two-dimensional array, I can't actually use match for what I know. I'm going to read up on that off screen. There is also some lookups, but I can't use those either. But since what I want to do is I have the values available when I'm doing the calculation, but I want to have a sorted set of them, so I can actually use a little helper here. Me neither for a year ago. So I can actually embed the coordinate in the number, but still keep the property of being sorted. So I know that I'm not going to have indexes in this array that are higher than 100, which means that I'm going to use Notepad because that editor is really bad. Notepad is not good, but it's possible actually to do some kind of indentation. So first I want my triangle because I don't want to the calculation of more data than I need. So let's put a big number there instead. What I can do is that instead of just adding them together, I can use I can offset it. So if I take this one times 10,000, that means that I still keep the property even if I add data on the 100 and the ones numbers, 1000 and ones, which means that I can actually add up here B A3 times 100 plus C1. So if I use that formula instead, sorry, something's off. It says that it likes, oh you're right, Excel doesn't like tabs, it likes spaces for indentation. Which basically means the exact same thing. Let's go. So we can fit everything together, and then that. So it looks really messy currently, but that means that if you look at this, for example, I see that I have the coordinate 02, 03, but it's still the value of 741. And since all columns that are not used is really high value numbers, I can actually instead here use one more column. Oh, sorry, I'm going to use it. Insert it here instead. And call that just call it cell value, then I take the sum A plus B, because this one is floor, or it's possible, by the way, to use an int. Runs exactly this one divided by 10,000, and I'm back on actually having a proper number, which means that it's C instead. But that means also that I can get the row and the coordinate out of this cell value. So let's just for fast use int this one divided by 100, and then I can use the mod, which mod is a function that takes the remainder of a division. So in this case I see that if I just to show divided by 100, that means that if I can get out I could cut off the first, the rightmost two values, numbers. So if I can cut off everything but the third, I can actually get the index. So in this case I use mod 100, and I have the coordinate. I can use almost the same, but I don't need first division, which means that I can remove a lot of numbers. Sorry. Yeah, it is, and I have used it when I'm doing a lot of times when using puzzle solving in previous round, because it's you need really now. The thing is that it's about actually a concept of what you can use Excel for. When you do programming, you can add variables, you can do arrays, you can do multiple dimensional arrays. And next thing is that you can manipulate those over time. Which means that if you have one array, but you manipulate that over time, you basically you do calculation in 2 dimensions, time and one linear array. So if you have a list of numbers, you say that every iteration I'm going to change this to that. You can do it. In Excel, which means that programming, you have 2-dimensional arrays, you still have the 3rd dimension of time. In Excel, I have only spreadsheets. I don't call the sheets, the tabs itself actually one dimension because you can't actually use dynamic addressing of in a proper way of sheet names. But in Excel, you have rows and columns. You don't have anything more than actually being able to use those two dimensions. So if you need some kind of concept of time, you lose one of the other dimensions. So you have rows and time, or columns of time, because you emulate time by doing the rows. So sometimes you need to be able to squeeze in data structures in those cells where you still have the rows and columns available. And the only way is actually to do bit packing, and packing like encoding. And I said it so many times. One of the worst actually was when I stored, I think it was one quite late, when there was this this puzzle where you have a grid of 5x5 cells and you have ants growing that they're reproducing, cellular automated basically. And then you had one dimension, so you basically had 3 dimensions, then you had to add time on that. Fortunately, I managed to do that because I could, it was just on and off on a limited node set, so I could actually encode 24 bits in a number. But it's really handy. So now I have the, so you need to be able to pack data. I can show you that later. But since we have the index, I'm actually going to use the index function. Index, which takes an array. It can be 2 dimensions, I think. And value A is vertical, I think. Oh, sorry. Oh, I'm going to use this one. Yeah. Almost like that, because I need to lock it also, so I can extend it. And therefore I'm going to use this one. So I think I had values. Just to verify, sum of those 3. It says sum 2020 down there. Which means that I can use the exact same concept as did in, I have my 3 values currently. So in part 1, I use this formula here, which I can be used here too. But I need to update it. So this one is H1. D E F2. And if not available, G2, right. So by this concept, I have the solution. I probably have the solution here, which means that part 2 solution should be equal to this number. And I'm going to freeze it also, because I'm going to, usually off stream, planning to actually write a little bit of description of how I do it. So if I solve this one and go to day 1, and I got the right answer, that means that I solved the first 2 puzzles in Excel. And yet it's just 1 hour stream. Cool. So I think that was a warm-up. Any questions, anything you want to see, if anything you're curious about? I expect to be harder and more fun puzzles in the future. Sorry. It's a simple concept, but in general we have actually managed to do a lot of things in the... Many of the tricks I was using last year with more advanced puzzles, we actually used here, like sorting. We did a two-dimensional, some kind of traversal mapping two numbers together. Also, packing data is really handy. We have not yet used priority queues, or at least queues in general. I actually didn't use priority queues last year, I think. I brute forced a little bit. So those are values to use. So I think that was a really quick stream. I expect to be longer puzzles in the future, and I'm planning to stream at least a couple of times a week. We'll see what happens. And I'm planning to use this time also. Hi Rudar. The Excel class with datakörkortet. Oh, welcome to future. I actually took the so-called datakörkortet just for fun because we had a possibility in school. Yeah, the input list went down from 200 numbers. Basically because when I looked at the input, the first concept is that if you have a number, we know that we should find a pair of numbers here, where, let's say we take A and B. If we have A plus B equals to 2020, if we then assume that A is less than B, because we don't have any 1010 in this array, we know that that gives that A is less than 10 in 20. Let's undo a bit. That means basically that from this we know that A equals minus B, that's known. And this set of equations can actually be written therefore to say that A is less than 2000. We rewrite it as B is less than, minus A. Which means that we can we know that everything is positive. So if we add up, so we get A plus A is less than 2020, which means that A is less than because we can do this, we see that A is guaranteed to be less than 1010. And that's the way how I was reduced it to be less than 200 numbers. So I'm trying to pick A less than 1010. So, but because then I know that B is greater than 1010. And by doing so, I can actually, if you look in this list, you see that it's a sorted list. So when I get above, I have just extended this list so that every A less than 1010 is in the list. Which means that I need to match it with a node number. In this case, I have added it to, so I calculate the other number in here. And then I'm searching for that other number in the set of input data. Doing so, I never need to actually handle the data. I have a lot, yeah. I can actually show you another solution I made also, which is of the fast part. But this reduction is only possible to do this far because I noticed that there are so many numbers that are higher and a lot less lower. So my other solution, I actually looked at the input data and did those calculations by hand because there was just 7 or so possible A's. Sorry. But let's see if I can find my other solution. This is a test, by the way, of doing the I made earlier. But just by the by using graphing calculator on the input, then the example data. This is not my proper set, but it's just those 6 numbers I have as an example. Because if I have x equals, if I have the input set n, and I set x equals n and y equals n, I get this grid, which can be seen. X equals n means the vertical lines. Y equals n means the horizontal lines. And that means that the sum of those is the distance from the origin 0, 0 up to this corner and then right. What we can do is that if we have that distance, we know that the sum is x plus y. We can rewrite x plus y, which should be 2020. So we need to add one value plus another one, should be 2020, which means this formula. So if we enable that, we know that solution should also be available on this line. And we can start by zooming in and see where are all those 3 lines intersected. And we see that here we have an intersection. Not here, that intersection is just only by 2 numbers, the 2 lines. 2 lines, 2 lines, 2 lines, and now we pass. Yeah, there's the 3. So we have 2 intersections available, which means that that one and that one. And looking at the coordinate for it, we can see that the numbers are 299 and 1721. 299, 1721. If you look at the original puzzle, let's go back. I have 2 stars, by the way. They say that 299 and 1721. So we can actually solve it by a graphing calculator also, and some graphs. Anyway, thanks for everything. Any more questions? Feel free to ask. Thank you to Freppa, and welcome to the stream, by the way. And we'll see. I'm planning to wrap up the stream. If you don't have any more questions, thanks for joining, and I hope you join more times in future. The thing is that I'm not really sure who to. I'm like rating people, but I can't find any Excel streamers online. I think it's hard. So should we raid? Well, let's raid a GeoGuessr player. Yeah, I know, but the thing about being Excel streamer is that you can't raid anyone. So yeah, a question, of course. Questions first. Are you there? Let's see if And did he come up with solving advent of code in Excel because Oscar said they could fix Merlin? Well, no. And then now I can know who you are. I did it actually because I had a colleague last year. One of my colleagues was introducing me to Advent of Code day 3, I think, with a comment that said that I think this should be possible to do in Excel. It was just one single day challenge. I think it was 2019, day 3. Not day 3, I think maybe day 2. It was the gravity test. Yeah, it might be the gravity test. No, this is int code. It might be that this was the 3rd of December. He showed me the first day and said that this should be possible to do in Excel. And I started doing it in Excel. And it was possible to do in Excel. And I did all the challenges in Excel because it's possible. And it's possible to do an int code version. So if someone says it's possible, I believe it's possible, and therefore I'm going to do it. But the monitoring system I actually saw made in Excel is a bit out of what I'm doing. That's really cool. Thanks. No more questions, or are there any more questions? Otherwise I'm sending you over to a GeoGuessr player, which is quite fun. And see what happens. I don't expect there to be anyone not playing Excel. So have fun at Jupiter. And see you soon. We're going to do like